Okay. Yeah. See here. Yesterday we have seen what is voltage, what is EMF, what is electric potential. Okay. And also we have seen what is definition of charge and current. So we have seen, we know that voltage is nothing but the potential difference between two charged bodies. One is positive charge or negative, another one is negative charge, or otherwise we can say that one is phase, another one is neutral. This is the thing we have seen. So, and also we have seen EMF, electromotive force, which is nothing but whatever the electrons are there, which are aligned in random directions because of the supply, because of the external energy, they are aligned in one particular direction, such
What
that
is mean by EMF?
electromotive force, EMF stands
Yeah,
for
definition, sir.
electromotive
Yes,
force.
sir. We know.
So when we give the force, when we give the force like battery, what happens is whatever the electrons are there, they will align in one particular direction. That means after aligning in one particular direction, they will move towards the, that means all these electrons will attract towards the positive terminal of the battery. So they are attracted
Okay.
towards the positive terminal. So which is nothing but electromotive force. Electro means electron, motive means motion, and force is the battery which we have given. So that is the EMF. Or electric potential also we have seen. The electric potential is nothing but work done in moving the unit positive charge. So which is nothing but electromotive force only. That means some work is done. That is V is equal to dW by dQ. That is the thing we have seen. And also we have seen the definition of charge. What is the definition of charge we have seen? So we know that in an atom, it is consisting of three fundamental particles. Those are proton, neutron, and
Electrons.
electron. So electrically it is stable. That means no charge. So when you by some means means by some external force or external energy, if we remove the positive charge from the atom, what happens? Automatically it will become negative charge. Or by some means in an atom, if I add some external electrons to it, automatically it will become negative charge. So which is nothing but the total or addition, the total addition or deficiency of electrons in an atom is nothing but a charge, which is a negative charge. That is the thing we have seen. And also we have seen Ohm's law. What is Ohm's law? At a constant temperature, whatever the voltage, that is a potential difference, is applied to the conductor is directly proportional. That means this potential difference is directly proportional to current passing through it. This is the thing we have seen. That means the graph is, as the voltage increases, current also must increase. That is the graph we have seen.
Mm.
And it is not applicable for semiconductors, because semiconductors will not, that means when you increase the voltage initially, there is no current because of the depletion level, such that after the depletion level breakdown, then only conduction is taking place. That means the graph is not obeying the ohm's law. So that's why it is not applicable to ohm's law. And also we have seen that some metals which are get heated up, and also gaseous elements which are, what happens, the electrolytes, all those things will be enormous gases are produced. Because of that, there will be no constant temperature. Constant temperature is keep on changes. That is why it is not applicable. Those are the things yesterday we have discussed. Now today I am going to discuss about the Kirchhoff's laws. Okay, there are two laws. It is
Yes,
Kirchhoff's
sir.
laws, not loop laws. Okay, there are two laws.
In Kirchhoff.
So some people are joining. Wait. Okay, not loop laws. Okay, there are two laws, that is Kirchhoff's current law and Kirchhoff's voltage law. We will see both the cases. Okay, wait ma. Let us see the Kirchhoff's current law. Here, here what I am taking is, I have considered around 8. Okay, I have considered 8 elements. In that 8 elements, how they are current are directed towards the node. Here node is nothing but intersection point. Okay, intersection point is there, no, that is the node we are calling it as. So some currents are I indicating as current. Okay, some currents are
Yes, yes.
some currents are indicated towards the node, and some currents are
Node.
indicated away from the node. So
Yes.
what I am going to tell you is, whatever the currents which are entering towards the node, those currents are leaving from it. So here in the figure we can see that I1, I2 and I3 are three currents are there. Those three currents are entering currents, and remaining I4, I5, I6, I7 and I8 is there. Those are leaving currents. You need to add two more currents here in this pin. Okay, so two currents are entering and two currents are leaving. So here entering currents, whatever the entering currents is there, I1 plus I2 plus I3, and leaving currents are there, no, I4 plus I5 plus I6, and you have to add I7 plus I8. If we not adding these two means no need of drawing this figure. Okay, eight elements are indicated means total eight currents must be there, and we have to see that whatever the currents are entering towards the node, all are added up, and whatever the currents all are leaving, they are given outside of the is equal to symbol. That means all are leaving. Okay, entering current equal to leaving current. So clearly we can say that sum of currents flowing towards the junction is equal to the algebraic sum of currents leaving the junction. Leaving or away is both are same. Okay, so here when you see that all these leaving currents are there, if I shift to left side, what happens? Left hand side, if I shift, automatically the plus will become minus. That means polarity changes. Okay, minus I4, minus I5, minus I6 and minus I7 and minus I8. Up to that we need to mention. Okay. Now coming to Kirchhoff's voltage law. Is the KCL is clear for
Sir,
all?
sir, once, sir, once scroll up, scroll up,
Yeah.
scroll up. Yes, sir, I need to write the formula. Sir, you are running with too fast, sir, go slow.
Yeah, I'm going slow only, not fast. Today only you are listening. Just now, just I explained only one topic, the KCL only.
Yeah, scroll down, sir.
Okay,
So what
you
about the
mm,
leaving current 8?
yeah, you just add that one. Okay, in the right hand
Okay.
side, you just add I plus I7 plus I8, and the here in the this is the arrow mark is clear for you.
Yes, sir.
Mouse is cursor is clear, no?
Yes, sir.
You
Yes, sir.
add minus I7 minus I8. Okay, here minus I7
Okay.
and minus I8. In the figure they mention
Okay,
means
sir.
you have to add minus I7 and minus I8. Okay, that is the
Okay.
thing I am mentioning here. We will see the problems also, no need of worrying about that. Now coming to KVL. Okay, in the KVL, what is the thing is, some disturbance is getting, please mute yourself. Okay, we will see with the KVL, Kirchhoff's voltage law. So this KVL, where it is applied means, here the condition is there. The condition is closed loop must be there. Okay, closed loop must be there, then only we can apply this Kirchhoff's voltage law. Here the thing is, here I am considering only one voltage source. Okay, so this is the voltage source ma. Okay, plus and minus is there, no? This is the voltage source I have taken, and remaining all what are they? Resistors R1, R2, R3.
R2,
Three resistors are
R3 are
there.
the resistors.
Okay,
Yes.
R1, R2 and R3. So already we have seen types of elements. Yesterday we have seen types of elements. Types of elements are two types. One is active, one is passive. Active elements means energy delivering element. Passive elements means energy absorbing elements. Okay, energy delivering, what are the energy delivering element? Voltage source. Okay, so here V is the voltage source which is going to deliver, because this is a battery. Battery is nothing but energy delivering, no? And these are the elements, receiving element, that is resistor, like a tube light, fan and a TV, like that they
Passive
are
elements.
connected in series.
Passive.
Okay, those
Yes.
are passive element. That means these
Passive
will
elements.
absorb the energy. So I have applied voltage here. What happens is, when there is existing a closed path, see here positive and negative, they are closed, no? Closed path is nothing but loop is created here. Okay,
Yeah.
so this is the loop. In the KVL, the condition is closed loop. Okay, in a closed loop, some of the in a closed loop, the algebraic sum of all voltages is equal to 0. This is the statement you need to mention. And the thing is here plus and minus is there, no? This is voltage rise. Voltage rise. Voltage rise means energy delivering element, and remaining elements are no V1, V2 and V3 is there, no? Voltage drops. Voltage drops. Drops means whatever the voltage is there, those voltage, that means suppose here this is 10. Suppose I have given 10 volts. Voltage rise is 10 volts. And together V1, V2, V3, how much should be there? This V1 plus V2 plus V3 is also
20,
must
20,
be
30, 10, 10
10.
difference.
Must
Yes,
be 10.
10.
Okay. That means
Yes,
10
sir.
I have applied means 10 volts should be consumed by that one, because it is a delivering, no? This is a voltage source is the delivering and the
Yes.
drops are receiving. That means sum of all voltages must be 10, like that. So in a closed loop, the sum of all voltages is equal to 0. That means here the thing is, yesterday all we have seen the direction of current, no? Direction of current from where to where we are, where to where it is going, from positive to
Positive
negative
terminal
only, no?
to. Yes, sir.
Okay. Always, that means conventional current we need to follow. Yesterday we have seen that the direction of electrons is opposite. Okay, actually the electron flow is negative is attracted towards positive, but the thing is the current direction opposite. For conventionally, for easy analysis purpose, what we are doing is always we will take the current direction from positive to negative.
Positive
Positive
Is
terminal
it
to
to.
okay?
negative.
So positive to negative you have to assume. You just take one paper, then you can write easily. Okay. So always you just write a note that always current direction is taken as positive to negative. So I have indicated the current direction here from positive. Okay. So from this current is flowing. So is there any other path? Is there any other path to divide current? Is there any other circuit here?
No, no.
No, no,
Only
sir.
one,
No, sir.
one closed, only one closed circuit is there. So only one
Yes.
closed circuit is there means, so the current will be only single current will be flowing in this path. Path is nothing but just like a road. Okay. So suppose if we see from Uppal to Ramantapur, is there any other path? Direct way is Uppal to Ramantapur only, no? So
Yeah.
likewise, that means only single way is there, single path is there. So there is no division of current. Okay. So current is same in all resistors. Okay. Whatever the current is there, it will be same. So here voltage rise is V, voltage drops are indicated with V1, V2 and V3. So always voltage rise is indicated with the positive. Always voltage, you can write that note. Always voltage rise is indicated with positive and voltage drops are indicated with the negative symbol. Or otherwise you can see that minus to plus current, how it is flowing. Voltage rise is nothing but current flowing from where to where? Minus to
Positive.
plus only, no? Okay. Minus
Yes.
current is entering from minus to plus. Okay. And here drops are there, no? Drops are there means current is flowing from, always the drops are indicated with, that means current
Positive.
starting from positive ending with negative. So resistor likewise we have to take this is very important, ma. Positive, that means current is coming from entering positive leaving as negative, entering as positive leaving as negative, positive and negative. So that means if current is entering from positive to negative, you just take with a negative. Is it okay? Here also minus V1, you can see the equation. The current here it is coming from negative to positive, that's why indicated with plus V, plus V. And here you can see that the current is entering from positive to negative. That means positive to negative, what you have to take?
Negative.
Voltage drop, no? From
Negative.
positive to negative,
Negative.
indicate with negative minus V1. Okay. Is it okay?
Yeah.
Similarly, this one V2 minus V2. Similarly, V3 positive to negative only, no? Current is minus V3. So that's why these are three are indicated with negative and voltage rise is indicated with positive. That means always we are, when you are considering, that means voltage rise positive means the current is coming from negative to positive and the drops are positive to negative. So if you can separate these equations, no?
Yes,
You can
sir.
separate these equations. All negatives are separated to right side. That is V1 plus V2 plus V3. And here it is left side, it is V1. That means we can also say the other equation. We can also say the statement like this. Previously, what is the statement we have mentioned? In a closed circuit,
The
algebraic sum
algebraic
of
sum of
all
all
voltages is
voltage.
0. Okay,
Yes.
algebraic sum of all voltages. That means this is the algebraic sum of all voltages is equal to 0. Now, what I can say now? What I can say now? Here I have written voltage rise. Here I have written voltage drops. So clearly we can say that the sum of voltage rises in a closed circuit. In a closed circuit, sum of potential rises or voltage rises is equal to sum of sum is nothing but algebraic sum
Yes, yes, sir.
is equal to sum of voltage drops. So that is the V1 plus V2 plus V3. So clearly either likewise this like this equation, or you can write this equation. Both are same meaning only. Okay.
Yeah.
Okay, sir.
Okay. Okay.
Okay, sir.
Let me erase this. Okay. We will. This is the thing. Sum of potential rises is equal to sum of potential drops. Already we know that. Yesterday we have seen Ohm's law for resistor. No, Ohm's law. What is Ohm's law? We got V is equal to how much we
IR.
got?
IR.
I into R. That is the
IR.
drop. So either we can write V or we can write I into R. Okay. So both are same voltage or current into resistor. So that is the thing we are going to write here now. So this is the statement we mentioned. No, sum of potential rises, or potential is nothing but voltage only. Potential rise or voltage rise, that is summation of V is equal to summation of drops. So drops are indicated with resistors. Drop is nothing but what? Passive element. No, so passive element is getting or not R, that is I into R. What are I into R summation? 3 drops are there. No, that is I into V1 plus V2 plus V3. No, that is the thing I am writing. What is V1? What is V1? Ohm's law. V is equal to IR only. No,
Yes,
yes
sir.
or no? So
Yes,
what is I
sir.
here?
Yes,
What is
sir.
I here? I only. No,
I current. Current.
Current.
current.
Yes.
Current I only. No, I is same.
Yeah.
What about R?
Yes, sir.
R in V1, what is
Resistor.
R?
Resistor.
R1. In
Resistor.
V1,
Resistor.
Resistance.
Wow.
the resistance is R1. Okay, resistance is R1. In V2, what is the resistor? Indicated with
R3.
R2.
R2.
Current
R2.
is same.
R2.
Current is okay. Current is same.
R2.
I into R2. Similarly, at V3, I into
R3.
R3.
I
R3.
into
V.
R3. Okay, that is the thing I have written here. I into R1 plus I into R2 plus I into R3. What is common here?
R1.
I.
R.
I.
R.
Current is
Common.
common. Current is common. Okay, I am okay. I have taken outside I into R1 plus R2 plus R3. So just like Ohm's law only, no, V is equal to I into
Yeah.
drops. Ohm's law we got, no, V is equal
V
to I
equal
into
to
R.
IR.
R equivalent.
Yes, sir.
I R equivalent. R equivalent is
Yes.
R1 plus R2 plus R3. And they are connected, no series. They are connected in series. Okay, there is
Yes,
no
sir.
current division.
Definitely.
No current division. Current
Yes, sir.
division is not there, means they are connected in series. If they are connected in series, resistor, how they are? They must be added up.
Parallel.
Okay. Now what you have to do is you just take one paper, switch on your videos, all of you. You just note down and tell me the value of voltage across in the individual fall. Okay. Find out the voltages, ma, all of you.
Uh, Tell me, sir.
Here
We have to draw
V1
this
is
circuit.
50. Yeah, draw
V1
this
is
circuit.
50. Okay.
At
V2 is?
R3, V2 you need to find, and
Okay.
V3 is 20.
V3 is
Very
20.
simple question.
R1, R2, R3?
Okay, very simple. Is it necessary to know the values of R1, R2? I want only voltage, no?
Yeah.
Just apply
No.
KVL. Just apply KVL and tell me the answer. Only one video I am getting. What about others? Okay. So just work out. Tell me the answer.
Wait, sir, we are doing KVL. We have 2 plus 50 plus
Tell me the answer. At R3, the voltage is 20. At R3, voltage is 20, ma.
20 రయ్యా ప్రతినాడు మెసేజ్ చూసుకో
By seeing only you can tell, no? Why you are taking that much time?
20 sir.
20, sir.
20.
Yes, sir, 20.
Sum of potential rises. Sum of potential rises is equal to sum of potential
Potential
drops. Here
drops.
potential rise is 50. Potential rise is 50. Here the drops are 10 plus V plus 20. Already
20.
drops how much? What is the drop voltage? 30 plus V.
30 plus
30 plus V
30
only.
plus V.
V. 30
30
plus V.
plus V.
30 plus V is equal to 50. Then V is equal to 50 minus
50 minus 30.
50 minus
30.
30.
30.
That is
20.
20.
20.
Okay, that is the voltage, 20 volts. Okay. Take this question, all of you. Take this question. Determine the current. Now you find out current and also find out the voltage drop across each resistor. What is voltage drop? Voltage drop formula is V is equal to we need to find, no, V is equal to I into R. So after finding I, you can get the value of voltage, no, because resistor is given, no. Resistors are given. Current you can find. And current, what is it? Is a series or parallel circuit? Tell me.
series.
Is there any
Series.
other? Clearly we can say that it is a series because there is no current division. Only one path from positive to negative. Only one direction is there.
Yes.
Yes or no?
Yes.
So this is positive at 10 volts. Positive. This small one indicating is negative. So current flowing from positive to negative. So current. So I can find current. No, I is equal to V by R. Ohm's law. What is Ohm's law? V is equal to I, or I is equal to
V by R.
I is equal to what? V
V
by
by
R. What is R? R total. R total. How they are connected?
R,
They are connected in
series.
series.
We have
So
to add.
they are connected in series means
8.1.
you have to add all the values.
Yes, sir.
Tell me the value of current. How much you got? Make it fast. Fast. Make it fast. Tell me the current. You have to use your Casio. Okay? You have to buy Casio.
2. I equal.
Do everyone follow?
Two, sir. I.
Sir, 2 I equals to 2.
Sir, I is equals to 2.
Sir, I equals to 2.
2.04.
Sir, 2.5,
only.
sir. 2.5.
2, sir, 2.
2, sir.
Sir, 2, sir, 2 is a.
Two only, sir. I is equals to 2.
2.5.
2.
Are you getting to the point? Find out the voltage drop. Question is not finished, no? Is question finished? Hello?
2.5 is current value, sir. We have to
I'm asking you.
voltage drop.
Voltage drop also you find out.
Okay, sure, sir. Voltage
Current?
is equal to
Current is 2. It is exactly wrong. Who got 2?
2.5, sir. Current. 2.5
Sir,
is
I
the
got
answer.
2.
Sir,
It's
2
wrong.
is current. I equals to 2.
No. Still anybody?
Sir,
2.04.
2.5. 2.5, sir.
No. No, wrong.
2.04.
No, wrong. It is in points. It is in points.
Yeah, sir,
Sir,
2.5.
2.04.
Not 2.5. It is a point decimal. Before the decimal only you are going to get. See,
0.2.
that is mega. Okay, that is
2
mega.
into 10
Ma.
power minus 6.
Yes, correct. 2 into 10 power of minus 6
Yes,
is
sir.
the
2 into 10 to the
value.
power minus 6.
Then everybody is saying 2. Okay.
Weird. కింద యాడ్ చేసి
Actually, it is in kilo ohms. You convert into mega ohms. Okay. You convert that into mega. Kilo means 10 power of 3. Mega means what? 10 power of 6. Okay. 10 power of 6. So you are going to get a 2 into 10 power of minus 6. So you can see that how you got I is equal to V by R. What is V? What is V?
10.
Voltage.
V is 10,
10
no? 10.
voltage.
What
Yes,
is
sir.
R? R value. R is connected
R
in series.
value
You have
2
to
into
4.
okay.
2. R
See
value.
here in the diagram. In the diagram, you can start from 3.1. Okay. 3.1 mega. Mega means 10 power of minus 10 power of 6 plus 6. Mega power, mega ohms, 10 power of 6. Okay. So I am writing I have to make unique, no? So kilo also I am making into mega. So 400 kilo ohms. 400 kilo ohms I can convert into mega. So 400 kilo ohms I am writing as 0.5, 0.4 mega ohm. How you will write 400 into kilo means what? Kilo means 10 power of 3. 400 is there, no? 4 into 10 square into 10 cube, 10 power of 5. You just added 10 power, you just multiply 10 by 10, multiply and divide by 10 by 10. What happens? It will come become mega only, no?
Yes,
So 4 mega ohms, 4 mega ohms by 10 you will get 4 by 10 mega ohms. How much? 0.4 mega. So likewise 500 kilo ohms also, what I am doing is kilo I am writing as 1000 and multiplying and dividing by 10 in order to make it into mega. So 500 I will get 5 into 10 power of 6 by 10. That is 0.5 mega ohm. So all are in mega. So I can take mega as common. Mega means 10 power of 6 is common. That is 3.1 plus 0.4 plus 0.5 plus 1 into 10 power of 6. I will get 5. The value is 5 into 10 power of 6. 10 by 5 is 2. 10 power of plus 6 is there. When it shifted to numerator, it will become 10 power of
10
minus
power
6.
minus
Okay?
6.
So that is micro, 2 micro amperes, not milli. It is mu. Mu means 10 power of minus 6. After getting the value of current, you can get easily the voltages drops. What is voltage drop formula? Current is same in all the resistors. So V is equal to I into R. What is R? Individually R values are different, no? So at V1, at 1 ohm, I into R, I is 2 into 10 power of minus 6. The resistor R1 is how much? 10 power of 6. Is it okay, that one? So 10 power of minus 6, 10 power of plus 6, what happens, ma? 10 power of 0. 10 power of 0 is 1. 10 power of 0 is value is 1 only, no? 1 into 2, 2. So similarly, the voltage drop across 3.1 mega ohm. So 3.1 mega ohm, that is I into R. You just multiply 2 into 10 power of 6 and R value is 3.1 into 10 power of plus 6. So you will have 6.2 volts. So similarly, you can get voltage across 0.4 mega ohm likewise. Okay. Did everyone got the same answers?
Yes, sir. Yes, sir.
Tell me. Is there any difficulty?
No, sir. No difficulty.
Okay. Now what the thing is, what is the total voltage actually applied?
Total
What is the
voltage
total
10.
voltage applied?
No.
10.
10. And you can verify KVL also, no? How you will verify? We know that KVL verification, how you will do? Sum of voltage rises is equal to sum of drops. Sum
Sum
of
of
voltage
the
rise is
drops.
10. What are the drops? Drops, how many drops are there? 4 drops are there. You just add all 4. How much you should get?
10, 10, 10, 10, sir.
10.
We'll
10.
get, sir.
Is it verified or not?
Verified.
10 only, no?
Verified.
It is
Yes.
verified.
Yes,
So,
sir.
so KVL is also verified here. 2 plus 6.2 plus 0.8 plus 1 is total value is 10. Is it okay, everyone?
Yes, sir.
Okay,
Okay.
sir.
So KVL is verified. Write down this problem. Determine the current in each branch of the following circuit. Here 50 amps is the current source. Current source is indicated with arrow mark. Is it okay? Current source is indicated with arrow mark. Previously voltage source is indicated with what? Dashed lines. Bigger line is positive.
Yes.
Smaller line is negative.
Negative.
DC means
Negative.
positive and negative. Okay, positive and negative. In AC there is no positive negative because phase neutral we need to mention. Because alternately it will go positive cycle, negative cycle. So in a DC you should mention positive and negative. So current source always indicated with arrow mark. And here what is the current source value? How much ma? Total voltage, total current source how much it is? 50, no?
50 amperes.
50.
50 amperes.
Okay, what you have to do? You have to find I1, I2, I3. Because current source, you also see that the direction. You also see the direction of current. 50 amps is entering
Positive.
towards the node. Here, okay. Here is there all are connected to common node only, no? See that I1, I2,
Yeah.
I3. Is there any resistor in between?
No.
Is there any resistor between I1 and I2? There is no resistor. So we
No,
can
no.
say that
Between
I1
I1
and
and I2.
I2 and I3 is there, no? That branch, that whatever the line is there, it is common. Okay. If resistor is there means there is no common. Is it okay? There is no resistor.
Yes, sir.
So that's why that total point is as common. So that means 50 amps is going to divide into three parts, three path, PATH paths. That is one path is through 2 ohms indicated with I1. Another path is 1 ohm indicated with I2. And another path is 5 ohms indicated with I3. What you have to do is only you
I3.
find the current I1, I2, I3. That I1 plus I2 plus I3 how much ma? 50 amps. So when you find the I1 value, I2 value and I3 value, the same answer
50.
you need to get. You need to get. Okay. Work out that one. Tell me I1, I2, I3. Anyone? Did anyone got? Only 1 minute is left. Make it fast. Anybody? You have to use calcis. You have to buy Casio Calci. New version, scientific calculator. Everyone has to buy because it will use for all 4 years. Okay, whatever the calci you are going to buy, scientific calculator ma. Maybe it charges around 600 to 1000. I don't know the value, present value. But anyway, you have to buy that calculator, everyone. Okay. Casio Calci 991 ES like that course. You can Google it. Tell me I1, I2, I3. Anyone? Less than a minute. Make it fast.
Bitch.
Why you are not switching on your videos? How I know you people are really working? You can stay idle also. I think if you switch off your video. Everyone has to switch on your videos. Tell me the answer. Make it fast. Did anyone finished?
Wait, sir, we are doing.
Mr. Vinay, answer. Mr. K. Vinay. Don't focus on camera.